Okay. So we learned yesterday that the cosine of theta was equal to what? If you had a parentheses here and you wanted to add two things like cosine of x plus y, it was what? Cosine of x, cosine of y, cosine, minus opposite sign, sine x, sine y. Cosine of x minus y was cosine x, cosine y, plus sine x, sine y. So it's cosine, sine. And the x and the y, x and y, xy, xy. Now we're going to learn today the sine function. So let's say we have the sine of a plus b. We're not going to prove this. We're just going to write the formula. So sine is sine, cosine, sine. Sine, cosine, sine. Sine, cosine. Same plus. These don't change. Cosine, sine. It looks like it would be easier just to say sine A plus sine B, but it won't work. So if you want to distribute this, the only way you can distribute it is by using this formula. Sine, cosine, sine. And here the sine, your signed, your operation stays the same. Double check it just to make sure. Yes, it's true. What about sine of A minus B? Sine, cosine. See, it's still AB. Minus cosine, sine. So it's cosine, sine, cosine, sine. CCSS, SCCS. Sine, cosine, sine. Cosine, sine. Okay, one other one. What about the tangent? Yeah, the tangent is the oddball. Tangent is probably one that's a little bit harder to remember. So this is in your book. If you have your book on 216, at the bottom of page 216, actually on 216 they have the sine and they also have the tangent. It's tangent A plus tangent B. They start out with the same signs, same operation, plus. Then on the bottom, instead of adding, we multiply them and we subtract it from 1. So it's 1 minus tangent A. See the opposite signs here. Tangent A, tangent B. Tangent. I don't know. There is no little formula for that one. It's just one of those tricky little things. Starts out tangent A, tangent B, then 1 minus tangent A times tangent B. Pretty horrible formula. Tangent A minus B. Tangent A minus tangent B over 1 opposite plus tangent A, tangent B times. So if you don't have a book, you need to copy those. Okay, so let's see if we can do one of these. On page 217, they got some examples. Suppose we want to find the sine of 75 degrees. And we whip out our unit circle, and we see there is no 75 degrees. Now you're saying, well, I just use my calculator. Okay, well, you can do that. You can hit 70 sine. Let's turn this on. Sine 75 degrees. Make sure that, let's double check that that's in degrees. Make sure you always, have that set to your right setting. Sine 75 degrees is 0.96592. And what happens when you write that down on the test? I counted wrong because I want the exact answer. I don't want an approximate answer. This is approximately. I mean, we could keep on going for the rest of our life writing that out, but that's not the answer. We want the exact answer. So what we want to do is break it down. We want it in terms of radicals. Okay, so we want this as sine 45 degrees. And you know why I do this? Because there's a lot of kids that don't watch this video and they don't attend class, and then all of a sudden they slap something like this down, and I can nail them for not attending. Okay. So what is the sine? The sine is sine, cosine, cosine, sine. Sine, cosine, and we'll keep the same operation, minus cosine, sine. 30. When am I writing 35 there? 30. Sine, cosine, cosine, sine. Sine, cosine, cosine, sine. See, the 45 and the 30 is still going to be first, second, first, second. That's not going to change. The only thing that changes is the function, sine, cosine. And the function changes to cosine, sine. So what is the sine of 45? Well, by now you should memorize that one, square root of 2, because it's the same for the cosine. So that's radical 2 over 2. And we could put it in over here too, radical 2 over 2. It's the same for the sine and the cosine. What about the cosine of 30? Cosine of 30 is radical 3 over 2. Minus. And what about the sine of 30? Sine of 30, remember the first one is the cosine, the second one is always the sine, 1/2. Or you could flip it over, 1/2. So you might want to make out a table like this, your major ones, and then probably be a good way to memorize them. So this is going to be radical 6 over 4 minus radical 2 over 4. So we could put the whole thing over 4. If the parts are over 4, the whole thing can go over 4. And we probably call that the answer. See, it's pretty easy. It's just kind of like what we did with the cosine, huh? Good. All right, let's try another one here. What's the tangent of 7 pi over 12? Now this one's a little harder because the tangent is a little bit harder. So we could write this as the tangent of what? 3 pi over 12 plus 4 pi over 12. That would add up to 7, right? But we want to reduce it. Tangent pi over, divide both of these by 3, divide both of these by 4. So what is the tangent? The tangent, I have a hard time even remembering this. That's equal to the tangent of pi over 4 plus the tangent of pi over 3, keeps the same sign. Then on the bottom is 1 minus tan pi over 4 times tangent pi over 3. Let's double check it and see if I got it right. Tangent A, tangent B, tangent A, tangent B. Okay, well, on mine, I kind of cheated a little bit, and I actually wrote the tangents on the outside here, or I have them in this table that I wrote. Save a little time. So the tangent of pi over 4, tangent is 1. That's nice. The tangent of pi over 3 is radical 3. 1 minus. Tangent of pi over 4, well, we know that's still 1. It didn't change. And the tangent of pi over 3 is radical 3. So this would simplify to, this is 1 plus radical 3 over 1 minus radical 3. You cannot do any cross canceling. So what we're going to do is we're going to try to get rid of this denominator here. We're going to try to rationalize this by getting rid of this radical. So we're going to use the conjugate. The conjugate is 1 plus radical 3. They don't want you to leave it in this form, so that's what they did in the book. They used the conjugate. So you could use a square double square on this, or you could just FOIL it out. This is going to be 1 plus radical 3 plus radical 3 plus radical 3 times radical 3 is 3. This would be radical 9, which is 3. Radical times radical. Okay, over, I could simplify that and do that in the next step. This would be 1 plus radical 3 minus radical 3 over radical 3 times radical 3, which is radical 9, which is 3. So when we do this thing with the conjugate, what it does is it always gives us a whole number on the bottom. So let's see what we get. We get 4 plus 2 radical 3 on the top. And then these two things canceled off. So we get this over 4. Could write the answer this way. All right here is where I goofed up. A negative times a positive is a negative. This would be negative 2. That's where I made my mistake. Now, what happens here, and I've seen this mistake like a zillion times, is that students want to cross off these 2's. You know, it seems kind of logical. They're both 2, we cancel them out. You can't do that. You have to factor out the 2. You can either put each part over 2, or you can factor out a 2. Now you can put this over negative 2. And negative 2 goes into positive 2 and negative 1 times. So this is negative 1 times 2 plus radical 3. Or you could just go ahead and distribute that as negative 2 minus radical 3. So you want to be very careful. Right here is where I see a lot of mistakes. I mean, most students do a very good job getting it down to this point, and then they try to do this quick cancel. Rather than trying to cancel it, it's sometimes better to factor it out. Then you can cancel off these, you know. Does that make sense? Because sometimes it's very, you know, easy to do that. How about the last one? We have something like sine 40 cosine 160 minus cosine 40 sine 160. So I see this as sine, cosine, cosine, sine, which is the sine of 40. Because there's a minus, this is going to be minus 160 in here. So that would be the sine of, and we could just subtract that, a negative 120. So what is the sine of a negative 120? Well, let's look at our unit circle. Just do it anyway. 120, but 120 would be over here, but we're using a negative 120. So here's 90 coming around this way, right to here. Here's a negative, that's the same as 240. Negative 120. And you want the sine, which is the second one here. So it'd be negative radical 3 over 2. I could write it here. Like that. See, that's how they got it. They're looking at this unit circle and they're going to negative 120. There's 90, 120. Sine, cosine. Cosine first, x position. Sine is in the y. See, it'd be the same as 140, 240, I mean. You could take 360, minus the 120, 240. You could do it that way, change this to sine of 240. You could also do that, Okay. Let's see what else we got here. It says write each function as an expression of the function of theta. See what they're talking about. See what they got here. Here they have the sine of 30 degrees plus theta. Okay, so they want us to expand that out. Sine 30 cosine theta. We don't know what that is. Minus, no, plus cosine 30 sine theta. Sine of 30, and you might have this memorized by now, 1/2 cosine theta plus cosine 30 radical 3 over 2 sine theta. Okay, so we see both of these are over 2. It looks like they really didn't do much to it. They just put them, kind of simplified it a little bit like this. But they can't really solve for theta. I mean, that's all they can do. They wrote the problem in terms of theta, but that's as much as they could do to it. Tangent 45 minus theta. Well, this would come out a little bit better because the tangent of 45, see, the tangent of 45 is 1. These you probably could memorize pretty easy. The square root of 2 over 2, square root of 2 over 2, because sine and cosine are the same, and then tangent is just 1. So that makes it a little bit easier. So what is this equal to? This is equal to the tangent of 45 plus the tangent of theta over 1 minus the tangent
Jocelyn?
45. Is that right? Tangent theta. Right? So tangent of 45 we know is 1. one is 1 times the tangent of theta. Okay, so we got it right there. And it looks like that's all they did. They couldn't rationalize this. They could have went ahead and rationalized it like we did this problem. That was the one we just did. I don't know what I did with it. Like we did on this problem right here. But apparently they just left it that way. They, you know. So sometimes it's hard to tell. This last one's pretty cool. The sine of 180 minus theta. This is sine 180 cosine theta minus, remember, sine, cosine, cosine, sine. So what's the sine of 180? Sine of 180 is 0. 0 times the cosine of theta. And what is the cosine of 180? You might think it's 1, but it's negative 1, okay? I just put it up here. Well, 0 times anything is 0, so this is gone. Negative, negative is a positive. So it's just sine theta. Kind of cool. All right, now the toughies. Let's see if we can do one of these. I think this is the last of the hard ones. Yeah, we don't care about that. Okay. Sine A equals 4/5. It says 1/2, let's see, 90 degrees is less than A is less than pi 180. So what they're saying right here, when they wrote this, they wrote pi over 2, that's 90 degrees, is less than A, is less than pi. Pi is 180. You can think of it that way. So if this A is between 90 and 180, that's saying it's in the second quadrant, huh? That's where A is. And we know that the sign should be positive in the second quadrant. So we know this angle is in the second quadrant right here. Cosine B equals a negative 5/13. So they're saying that pi is less than B is less than 3 pi over 2. So what they're saying right here is this is between 90 and 270. So we know that that's going to be the third quadrant. You know, they could have just come out and told us, but they're trying to be a little tricky. So this is in the third quadrant. This is in the second quadrant. And what we want to do, and I'm going to do it different from the book, and we'll see if we come up with the same answer, because I like to do it by a different technique. So I know this, I'm going to draw it down here. I know this angle is in the second quadrant. So what is the sine? The sine is the opposite over the hypotenuse. So I know this distance right here is 4. I know this distance right here is 5. And I know this is a 3, 4, 5 triangle. My drawing isn't so great. But this would be 3, 4, 5. And this would have to be a negative 3 if it's in the second quadrant. 3, 4, 5. Right triangle. I could find this 3 by using the Pythagorean theorem. Okay. The other one I know is in the third quadrant. So I'm going to draw it like this. And this is the cosine. So the cosine is the adjacent over the hypotenuse. So I know this is -5. I know this is 13 down here because this is the hypotenuse. And I've seen this so many times. This is a 5, 12, 13. If I use the Pythagorean theorem, this is going to be 12, but this is going to be a -12 because it's going down. That's why I want to draw them in the correct quadrants. Okay. So this one was in the third quadrant. This was in the second quadrant. So if I know the sine of A, now I need the cosine of A also. And the cosine of A is going to be negative. It's going to be the adjacent over the hypotenuse. So it's going to be -3 over 5. -3/5. If I know the cosine of B was this, now I need the sine of B. The sine of B is going to be the opposite over the hypotenuse. -12 over 13. See, and that makes sense. In the third quadrant, the sine and the cosine are both negative. In the second quadrant, the sine is positive, but the cosine is negative. Okay, now what are we going to do? Okay, so now we want to figure out what are we trying to find on this one. We want the sine of A plus B. So we're going to expand that out. That's going to be the sine of A cosine B plus cosine A sine B. Kind of fun, huh? Sine, cosine, cosine, sine. I guess one definition of fun is not the same as another person's. Okay, so I want the sine of A, 4/5, but I want the cosine of B, -5/13. Going to times those. I want the cosine of A, and that's why we had to find this. And I want the sine of B. That's why we had to find that. See, we could have done the first part, but we wouldn't have been able to do that part. Notice they both had the same denominators. So this is going to be -20 plus +36, if I did my math right, over 65, which comes out to 16 over 65. And let's see if that's what they came up with. Yes. So this is the answer to the problem. The cosine of A plus the sine of A plus B, quantity A plus B, is 16 over 65. Now, they did it by using sine squared theta plus cosine squared theta equals 1. That's another way of doing it. I personally like to do the drawings. I can see the drawings. Plus, I have these pretty well memorized, 3, 4, 5. These are usually give you nice numbers. 5, 12, 13 is also a triple. So it might be one, you probably know the 3, 4, 5. But this one's good to know, the 5, 12, 13. I actually had a student to come last year, a couple of students worked together and developed a whole chart of these by a little formula. They came up with a formula for devising them, which I thought was pretty cool. And I don't have it handy, but they came up with a technique for finding all these, what we call Pythagorean triples. So, but these are two that come up quite a bit, the 3, 4, 5 and the 5, 12, 13. And you could double check it, 5 squared plus 12 squared, that would be 25 plus 144 equals 13 squared, 169. So these will add up to 169. 9 plus 16 is 25. 5 squared is 25. So they will check. Now the tangent, this next example, I'm not going to work it out, but the tangent is a little bit harder to do because you run up, well, maybe we should try it, huh? Let's try that tangent. It's a pretty messy problem. I'll try it, but usually the tangent is not a lot of fun to do. The tangent of A plus B. Okay, well, they gave us this information right here, right? But they didn't give us the tangent. See? So we can go back to our diagram and try to find a tangent of A and a tangent of B. This was A, this was B. This was angle A, this was angle B. So the tangent of A, what's calculated right here? The tangent of A is going to be the sine over the cosine. So it's going to be 4/5 over or divided by, let's put divided by -3/5. It's going to be the sine divided by the cosine. And we have the sine and cosine. We figured those out. So this is going to be 4/5 times 5 over -3. 5s are going to cancel out. So the tangent of A is going to be a -4, well, let's make the negative on top, -4/3. Now let's figure out the tangent of B. Tangent of B is the sine divided by the cosine. Remember, we flipped these over. Maybe it was a good idea to do these. These will cancel. So I know the tangent of B is 12/5. Okay, so we can use these diagrams. See, that's why the diagrams to me came in handy, because now I can easily find the tangents also. Because, I think using this doesn't help me as much. So I like the diagrams. So let's see if we came up with the right solutions for those. We want to make sure that we have them right. So it says to find the tangent, blah, blah, blah. So they calculated out and they figured out the tangent was -4/3, which we have, and 12/5. So that's what they did over here in your book. They calculated it out. Now let's see if we can solve this problem. What is the tangent of A plus B? Well, that's equal to the tangent of A plus the tangent of B over 1 minus the tangent of A times the tangent of B. After you write these out a few times, you just kind of memorize it. I think, I don't know, hopefully. This gets into a lot more messy fractions. -4/3, we got that one figured out, and we got this figured out, plus 12/5. Want to make sure you get your signs correct, let's double check them. Yep. And then 1 minus a -4/3 times 12/5. See, that may be better. There we go. Thank you. Okay, on the top, we're going to do that little, I'm running out of room here. Let me get another sheet of paper. On the top, we're going to do the crisscross applesauce. So 5 times -4, -20. Multiply those two. Multiply these two. Positive 36 over 15. Which will simplify to 16/15. On the bottom, we're going to times these out. This is 1 minus a negative 48 over 15. Chick, chick. 1 we could rewrite as 15 over 15. (15 plus 48, 63). So you have 16/15 divided by 63/15 divided by. So all we have to do is flip this over. You could write the divided by, but I'm going to save a little bit of time. I'm going to flip that over. That's going to be times 15 over 63, like that. Or another shortcut we can use is we can just cross off both of these 15. When you have a fraction over a fraction, if both these numbers are the same, you can cross them off, you see, and what do we end up with? 16 over 63. And that should be the answer to this problem. And we take a look, and yeah, that is the answer in the book. So here we had to do a lot of work with fractions, okay? Criss-cross applesauce, 16 over 15. Here we had to multiply these out, but we changed the 1 to 15 over 15. Then we had a fraction over a fraction, but both denominators are the same. So we can actually use a little shortcut. 16 over 15 divided by 63 over 15, just to visualize it, would be 16 over 15 times 15 over 63. See how the 15s cancel out? And you get 16 over 63. So on a complex fraction, you want both those numbers to be the same. Just a kind of a short way. If that bothers you, then write it like this. But you see how we had to take the first problem to help us find the tangent, because they didn't give us the tangent. It was kind of hard. So we had to use these values that we got from the first problem to get to the second problem. We're not going to try the third one here. Confusing as heck. Okay. Well, it's fun. But I know some of you don't like fractions, but it's good practice on the fractions. You get better at them. I'm not going to do that proof. So, yeah, I don't think you have to worry about it. So, look in your book. Let's do one more problem. I guess time's up. Okay. I want you to try some of these, and then tomorrow, bring in all your questions. We will try them, go through some. You now know these two sections, and let's close this out so you can get something to eat. I'm sorry about that. Okay.
Thank you, Mitchell.
Okay, we'll see you then. Wait a second.
Have a good rest of your day.